Why, hello, hello, hello. This is the Julia Dispatch coming at you with your host. I'm Chris Rakakis,
And I'm Michael Tiemann.
and we are coming here with a very special guest today to start everything off. Right, so this is our first regular episode. We will have other videos that will talk about what we're doing and also what our other plans are. Right, this is just one method of that we plan to discuss with all of you. Because again, as with Julia, we cannot just have one method, right? So the Julia Dispatch will have multiple ways that we're doing lots of things. We'll share all this with you. But today we have something special. So let's get right to it. Today we have Dr. Tim Holy. Would you like to introduce yourself? How would you introduce yourself?
Yes, my name's Tim Holy. I think the best way to introduce myself is I'm a joke of all trades, but I am a professor of neuroscience at Washington University in St. Louis, and I am an avid Julia user and developer. I'm one of the sort of old timers in the language and ecosystem, having discovered Julia shortly after the 2012 blog post came.
Yeah, so this is something that is really interesting me. Um, you started contributing and like committed yourself to Julia and committed to Julia very early on. Like, how did this end up happening? Yeah.
Yeah, it was really, I mean, like so many of the important decision points in life, it was really just a sort of a happy accident. So I was not in the habit of checking programming blogs or, anything like that. I'm a neuroscientist, but my lab has sort of two arms where we're focused on science, but we also develop new tools, molecular tools, imaging tools, computational tools to tackle problems in neuroscience. And my lab was one of, I guess, five independent co-inventors of a technique that's now called light sheet microscopy. Um, and we were therefore among the first people to really start getting just huge, huge reams of imaging data from this. So, most of the previous techniques for collecting images were much slower than our new technique, and so we were suddenly faced with data volumes that were much bigger than anything we could handle. And I was a user of another programming language before, and I was in a habit of doing an annual survey of where my development efforts were going. And I discovered when I did this belatedly one year, I usually tried to do it as sort of almost like a State of the Union in January. I did it in March of 2012. And I discovered to my horror that I had spent my entire year basically writing glue code between C and this other language that I was using. And I just lost faith basically that it was worth me putting any more time in that other approach, and started Googling for alternatives, and just happened to run a search that came across Julia. And so I spent a couple days just reading my way through the manual, which was already surprisingly good for a brand new, language at that time. I mean, very different from today's manual, but still it was surprisingly well written and all. I learned a ton from reading it. I mean, again, it was not something, it was all really quite new to me, but I very quickly sort of saw the potential this had for our research group. And so I did a few demos, and the performance was, after I learned a couple of, to avoid a couple of mistakes, it was everything I could have hoped for. And, within about a week or so of starting on Julia, I was sold that this was definitely the future for
Though,
my lab.
though, what really made you take that leap of faith, right? Because you're saying before even the first Julia release, right? You were
Yeah.
you were you were there before the thing was 0.1, right? So
Yep.
what made you take that leap of faith to say, you know what, I believe in this project and I believe that it will continue. It won't die next year. And like, what gave you this faith?
Yeah. So okay. So the question of whether it would die next year was definitely a relevant question, right? But nevertheless, it seemed that there was an awful lot of momentum when the Julia blog post in 2012 came out. It really caught a lot of eyeballs, and so at least in that sort of early phase, I think there was enough enthusiasm around Julia to give me the confidence that this maybe was something that had legs, basically. To be fair, I think there were sort of went through winters subsequently, right, where the road is actually very long, and there can be an initial burst of enthusiasm, but it's really the prizes go to people who have the determination to see it over the long road and not the short one. And so anyway, so I was a little naive about these things at that time. So I was convinced by the burst of enthusiasm that this was going to be great. And so that was one of the things that did it. The other thing that really, it's so funny how these sort of the accidents and human interactions work. I was one of the very first Julia users. I think Julia had been like piloted in a class that I think Alan Edelman taught at MIT basically, and there were lots of people who looked at Julia, but very few who really sort of jumped in. And so I was one of the sort of early people having communications about Julia on GitHub, for example, right? And I remember one of my early days of using Julia, I reported a bug, and Jeff Bezanson, who's the main sort of designer, if you will, of many aspects of the language, I think he fixed that bug in about 45 minutes or so. And that was a very compelling experience for me, right? Because as I've said to others, so maybe I'll reveal. I had a calendar entry in my calendar to re-report a bug in the existing software that we were using on an annual basis, and I'd done that for 10 years without getting any action on that bug, right? And so when Jeff fixed this thing in 45 minutes, it was like, okay, this is really powerful. So, open source was working, right? So,
yeah. Well, and then open source was really working, right? Because after he fixed your bug, right, you decided like, oh, tit for tat, if I do things, then you also do things. And so what were the first contributions that you started in doing there?
I'm not sure I remember the very first what the very first contribution was. I do remember that basically I reported several bugs, and Jeff and maybe Stefan fixed some of them, quite quickly. But eventually I got to a point where I reported a bug, and it was clear even to me that this was a little bit more niche, right? Some of the my first one was an obvious thing that just had to be fixed right away, basically, right? Again, I don't remember what these things specifically were, but eventually I reported a bug that was clearly more niche and not maybe a super high priority, and it lingered for several days or a week or whatever. And I'd had fairly extensive programming experience before. I was a C++ user in grad school and all. So not that anything I did early on required that knowledge, but I had some amount of experience writing code. And I said, well, this is an open source language. Maybe I can fix it. And I dove in and fixed my first bug and submitted my pull request. And, in that era, I barely even knew how to use Git, right? So, I was using Subversion for my lab.
It was popular back then.
Yeah, exactly. That's right. So, but I learned to use Git while I was also learning, to do Julia development basically. And one thing kind of led to another, and it was pretty clear that it was very clear to me early on that not only was this going to be person power limited, but that I also actually had a chance to ensure that this would move in a direction that would make it useful for my lab, right? And so it, there was a certain point at which I got slightly more realistic about it, and like, okay, this might require quite a lot of investment from me, but at the same time, I can ensure that I and colleagues I care about, have a tool that will really, really serve their needs well in a way that nothing else I see out there will do. And so, at that point, I think I became a little more consciously, if you will, committed to the future of Julia.
So was there ever a point where you maybe like in the State of the Union 2013 or so, where you thought, oh, I'm not yet sure whether I will be in it forever? Like, was there ever a point when you was like, okay, maybe I'm gonna at least test other options out there, or was it already clear by then that okay, this is where I'm going all in?
Yeah, it was. So first of all, this was early enough that Python was not really. Python was taking off big time right around 2012, right? This was the AlexNet era also, right? But Python was taking off, but it had not yet reached sort of the stratospheric heights that it it is at, now, in terms of its importance to for instance, the scientific computing community. And I'd experimented with Python and had some really bad experiences in terms of its performance for the things that I do. And I'm all, a lot of the things that my lab needs, yes, some of it is linear algebra, but a lot of it is really bespoke analyses where we're pushing things onto a priority queue, and then we're popping the next item off and doing one little bit of work, and then pushing more things onto the priority queue. And all of these are kinds of things that just don't fit the development model of, and I actually think many programmers underutilize those types of tools in their scientific code development because they just know that it's not possible in the language that they're coming from, right?
Or why don't you just make all your students learn C? Why
Right,
not have
exactly.
every neuroscientist? Yeah.
Exactly, that's right. And so, Julia means you don't have to deal with some of the negatives of a very low level language, but you get all the performance advantages of a very low level language. And so, so for me, Julia was just so enormously productive. And it was frankly such a huge improvement in terms of sort of the beauty of the language and the code that I could write, that really there wasn't ever a moment of significant doubt. And I was getting, so in those early days, yes, I pretty quickly became a Julia developer. I mean, one of the first really big things I did was I added support for memory mapped arrays because my lab was getting really, really big data sets and Julia couldn't open the files, So I think that was maybe the thing that got me commit access to the Julia repository. I'm not actually sure I remember that history properly. And then probably my first really, really kind of big impactful change, I would say, was probably, creating the profiler, basically. So because I wanted to understand when I hit poorly performing code, I wanted to understand why it was poorly performing. And there were lots of gotchas then. There are still gotchas, to this day. You can always write slow Julia code, but there are far fewer, I think, of those today. Although, to be fair, I'm also just better at knowing how to avoid those than I was when I first started out. So anyway, writing the profiler was a big part of me wanting to make sure my lab's code was performing appropriately. So, in those early days, I put in some amount of time into Julia development proper, but I spent a lot of time just writing my lab's code base. And so very soon I had what was probably the largest, code base in the world of Julia code outside of, Julia proper, basically. And we were at that point very committed to the language, and so at that point it just became making sure that it was going to be viable for us.
Yeah. So one thing that one thing that happens with Julia itself is that what you're talking about here is you're talking about like, oh, you did neuroscience and you created this array type. These are all features on Julia, but there's this scientist to compiler engineer pipeline, right?
Yeah.
So
Yep.
and you made that transition. So because you now work on things like inference and stuff. Like how did that happen? Did you just go, oh, the brain's a compiler, so why not just learn this too? Like, well,
no, that's
you...
not. It was entirely driven by practical need, basically, right? So in rough terms, I think there were basically two inputs to that to me sort of getting into that world. So the first was, when I joined Julia development, Julia didn't even have packages yet, and so I sort of witnessed the creation of the first packages, and actually images.jl might have been the very first sort of kind of a package, and it was basically split out as it started its life as a big demo in the Julia repository itself, effectively, right? And then sort of split it out and made changes to it, and then it was either the first, or it may not have been the first, but it was certainly in the first.
Well, I wasn't around, but I do hear people say distributions.jl beat you or something.
Oh
like
yeah,
that.
that's probably actually true. I mean that actually rings true, that it actually, like, I intended it to be first, but I was busy making some other Julia change, and so it wasn't the first. But it was very early on. It was one of the things, and one of the things that very quickly became apparent basically was that in the early days, when you loaded code, Julia would actually warn you about ambiguous methods. So what an ambiguous method basically is, if you have a method that takes two arguments, in Julia you can actually specialize methods on which types of arguments they accept. But you can get into a situation where you may have one method that's specialized on the first argument and another method of the same function that's specialized on the second argument. And the question becomes, what if you satisfy both of those specializations, which one of those gets called, right? So that's called a method ambiguity if there isn't an even more specialized method that is more specific than either of those other two. And so early on in Julia's time, it would actually emit a warning when you loaded the package. And as we didn't need very many packages until it was you'd sometimes get screens full of warnings. And it seemed pretty obvious that was going to be a pretty big threat to developing a vibrant ecosystem.
Mm-hmm.
So one of my early steps into the compiler was sort of figuring out how to convert those warnings on loading to errors when you try to actually call those methods. So that was so basically it was my desire to pave the fact that there was this problem out there and it didn't seem like anybody else it had been out there for, at this point, half a year or something like that. Nobody else was tackling it. And I said, but really, we clearly have to make a future for the package ecosystem. And again, it's not like nobody cared about it or whatever. It's just there were, at that point, so many things to do that it was just a question of what people's immediate environment pressured them into deciding to be worth tackling. And I decided, maybe I can learn something about these method ambiguities and figure out how to resolve them. So that was one. The second thing that really drove me into the sort of compiler and tooling world was because I cared a lot about big arrays. I was one of the sort of, so Julia already had an array type, when I sort of, signed on to the project, basically, right? And it was really quite impressive, but it was also very sort of hardwired, if you will. And I fairly quickly realized that there were lots of operations that would be naturally expressed as array operations, but for which there was no ability to really do so. And in part because of I started.
Share a concrete example of that,
I mean, a good example of that is what is today a subarray, right? So I believe we actually had a type called a subarray, early on, but it had, some fairly poor performance, and it was fairly limited in terms of the kinds of things you could do. If it might have even needed to be strided at the beginning, and so if you want to do something like, we collect these giant movies, and if you want, to pull out a 5-second snippet around every time you deliver a stimulus to the animal, that's not strided because those episodes come at unpredictable intervals and they're bunched together as, all this kind of stuff, right? So I wanted things to be a lot more flexible than they actually were. So I started thinking pretty hard about how to resolve that problem. And there were other people in the Julia community at the same time. A real hero of this work was also Matt Bauman, who is another neuroscientist and who I was clearly, he's a very gifted designer and was clearly thinking along these lines as well. And quite a few other people were sort of moving this direction as well. And so over time we started sort of figuring out what was the sort of, what was it that we wanted to achieve? And the big question, I think, was how to achieve it. And what we realized, and it was in part because of my work on the ambiguity problem, I realized that the hard problem that needed to be solved is how do you provide rich array behavior while still allowing people to specialize, right? So the idea is basically you want to be able to create a custom array type, right? Something that does something cool, right? To have a stupid example, what about a little small object that just encodes the square of integers, right? And you make this like an array of a certain number of integers, right? It's a useless thing to do, but like you could naturally express that as if ranges are a good example of something like that, right? What if you wanted to create something that instead of being unit-spaced ranges, you wanted to create logarithmically spaced ranges or square-spaced ranges or something like that, right? You might want to be able to do that and think of it and treat it as if it's an array. And so what we realized we needed to be able to do was provide very limited points at which package authors could specialize certain methods, but then have fallbacks that would handle all of the slicing and all of the other things that you might want to do with arrays as well, and not force them to implement that part of the process, especially each and every time. And so it became a big design problem. And how do you provide these fallback behaviors without there being ambiguities in terms of specialization? And Matt and I spent quite a long time going back and forth on GitHub. We worked together for years, I think, before ever meeting in person. And we finally sort of cooked up a design. And basically, there were two big things that needed to be done. The whole array interface needed to be created, and Matt ended up doing vast majority of that work. But we needed one thing from the type system. And basically, that thing is what became var arg of t comma n for Julia users. And it did not, there was no n originally after that. And for our work on arrays, we really needed that n there. And so I decided to tackle that problem. And that was basically a 2-month-long dive into Julia's type system for me, basically.
So it only takes 2 months to learn it.
Right, exactly.
So if I'm going out on a limb here, isn't that also the occasion where, like, in the connection to this problem, the holy trait pattern was born?
It was related, but it's not. That's actually a little different. So that the so-called holy trait pattern is basically arose out of frustrations with a union type that we have that's called strided array, basically. And basically, this is effectively like a multiple inheritance problem, right? If for people who are familiar with that concept from other languages. And so in Julia, we have a way of doing that where we can at least bundle a bunch of objects together and say they're part of a named set of properties. But if you do it by the union, it's static. You can never again add any new thing to that. And I was just looking for a way to make that more dynamic. And basically the so-called holy trait pattern was me simply realizing that Julia's dispatch actually kind of gave that as a side effect, as an automated consequence. It was kind of surprising how long it took all of us to actually realize that that was the case. So
we might want to explain to new users or people who haven't heard about it. What's the Tim holy trait pattern?
Yeah, so the trait pattern is the following, basically. So let's say that you have, again, thinking about arrays, right? Some arrays might be densely packed, others might be sparse. They might have, properties where they're storing string data or numeric data. They may there's all kinds. They may be ordered in different storage orders in the computer's RAM. All of these different characteristics, and these characteristics can govern which, for instance, algorithm might be most efficient for performing some task on them. And so you'd like to be able to sort of direct Julia's dispatch mechanisms and the compilation of the code to be sort of optimally tuned to the specific type that is there. And the idea is that rather than creating these unions that are then sort of closed once you've created them, maybe a better thing to do would be to have a set of functions that just return effectively the tags, the traits, if you will, that certain arrays have. And basically what the realization of why dispatch solves this problem is, what if you just add the values of the traits as extra arguments to the function? Now this gives you arguments that you can dispatch on, and then that allows you to create multiple methods that essentially catch the dispatch from passing in an argument.
And I mean, yeah, the real key trick, the real key here is that it all happens at compile time too, right?
Yeah,
So
it all happens at compile time. Exactly. Yeah, that's a key part of this, is that for things where the runtime query would actually be a measurable amount of overhead, this trait pattern is very useful because it's a fully resolvable at compile time, and that's the real value of it.
But it seems to me, excuse me for saying so, you're not completely enthusiastic about the name that people associate it as the holy trait pattern.
I guess I'm honored for sure, right? But it's also kind of funny that I've lived my whole life with lots of things being named holy. Most of them are churches and Bibles and things like that, right? So aside from me, so anyway.
So as a newcomer, when I started diving into the language, I read this one book about best practices working with Julia, and then learning about the holy trait pattern, and that there's holy traits. I consider this a feature of the language.
Yeah.
Like that is
Yeah.
his very strong selling point.
I mean, to be fair, I mean, I think traits are they're. I'm also a fan of doing runtime queries when that makes sense, right? You don't want to solve all problems with the compiler, right? That can actually
Mhm.
lead to bloat of its own form, right? But
Well, that's the next topic. Yeah.
yeah, exactly. That's right. But it's absolutely essential in certain cases to have the ability to allow the compiler to make decisions. And this is one of the powers of Julia. It also places demands on the developers of Julia is to know when to leverage a runtime check on something and when to leverage a compile time check on that. And it's very understandable that newcomers to the field may not always have the best judgment in that. I certainly have learned over time how to calibrate my own thinking in that domain.
So speaking of compile time changes and such, right? So you really started with building out your code and starting getting the compiler, right? And the language just started growing, right? It kind of took off, and people started building these huge codes. And after people started building these huge codes, you started having to worry about workflows, right?
Yep.
So what projects did you start doing when you started going, wow, we have these massive codes. How do we start to handle a massive Julia code base? So how did you start to what did you start doing at that point?
Oh yeah, no, it was very, very frustrating. This is so as I've said to many people, I actually kind of tried to ban usage of Julia for anyone besides myself in my lab in the early days. And the reason why is that it was very painful to do the development on, because since it was a compiled language and yet an interactive language, in the early days we had to essentially shut the Julia session down and restart it in order to make, to see the impact of making code changes. So, I kind of felt that, especially as our code base started growing, I was really suffering a lot from, the sort of those Julia restarts and all. And so, and I mean, I was far from the only one. I mean, this was acknowledged as a really, major issue basically. And so at a certain point, Jameson Nash, just an enormously talented developer who has a much deeper understanding of the compiler than I do, did, especially at that time, and even to this day, has a much deeper understanding of the compiler than I do.
He is the compiler.
Wait, what?
He is the compiler.
Yeah, in some ways, that's right. That's right. The Ask Jameson algorithm is pretty famous, right? So he really bravely decided to tackle this. So there was a famous issue. It's one of actually the few issues that a large fraction of the developer community knew by number. It's issue 265. So it's a very early filed issue in the Julia repository. And Jameson famously solved issue 265. And this was an enormous effort. It really required an extensive redesign of a lot of the internal data structures of the compiler. He introduced the whole world age mechanism. For those who have heard about that, it basically is what allows you to say this method is no longer applicable, basically. And that really was the ticket that opened the floodgates to making Julia much more productive user experience. That said, Jameson's work alone was a little hard to leverage because you had to reevaluate every function that you wanted to modify to trigger it, and you had to remember which code you'd edited and which code you hadn't edited, or immediately reevaluate it. And if you're partway through it, and all this kind of stuff, you might break something internally. One of the challenges of modifying code, that since so much of Julia is written in Julia, there's a little risk factor in modifying methods, because you might break the code that then is looking at that, right, or is incorporating that somehow. So anyway, so there were lots of interesting sort of challenges there, and I just found that very quickly, even though as amazing as Jameson's work in this area was, it was very hard to actually sort of scale to easy development of large projects. And so I think where your question was directed, Chris, was I created pretty shortly after Jameson's work came out, actually started it on a plane ride back from JuliaCon.
Yeah. The JuliaCon Berkeley, right?
I can't remember which one it might have been. Yeah, exactly. But Jameson's work had landed quite, shortly before that, basically. And One of the things I always love about JuliaCon is the hackathon, and for many years I had a promise to start some big new ambitious thing basically at the hackathon, and that year I had family commitments or something that meant I couldn't attend it, so I used the plane ride back to start something, and I started Revise.jl, which basically sort of automates the process of reevaluating your methods that you've modified to take advantage of Jameson's work. So it's essentially, if you will, the automated friendly wrapper around the core compiler infrastructure work that Jameson contributed to the, to that whole thing. And I think it certainly changed my experience of using Julia there, and I think for others as well that
it's a standard, yeah.
Yeah, it's I think it's it's what allows Julia development to be fun and efficient basically. So
it works
and
like
I think
magic.
that it can't do everything, but it does a lot. So yeah.
I just want to kind of, before we go to the next section, I want to go through the greatest hits album. I bring up in the Tim Holy's greatest hits album, I think that there's a 2019 contribution of, or 2020 of, packages and compilation of packages, right? So what happened, so what got you to really just say, I'm going to solve this problem of Julia is a just-in-time compiled language, but you did a few changes there, right? So that way you could do a lot of things ahead of time. Can you describe a little bit about what you did and where that made your changes? And because I think that brings us into a lot of more of your current focus, right?
Right.
So
yeah.
Describe a bit of that.
Okay. Yeah. Sure. So after Jameson's work on 265 and Revise and all, it seemed that maybe even as early as like 2017 or 2018, I can't remember exactly, right, that the next big usability challenge for Julia was the fact that when you started a Julia session and you would load a bunch of packages, the Julia definition of the methods would be loaded, but the compiler would need to go to work on any code you actually wanted to use and start compiling it. And compilation is an amazing, beautiful, and complicated enterprise, and it takes some time, right? And there are many stages to Julia's compiler, and each one of them adds to the amount of time it takes. And so anytime the part of the motivation for Revise was because basically if you needed to restart your Julia session, you could sometimes pay a pretty substantial price in terms of getting back to where you were before. And this was not measured in seconds. Sometimes this was measured in minutes or even longer, right? So that again was
I'm the adversary there.
Yes, exactly. Right. Yeah. No, exactly. You've been a stressor of that whole systems even more than I ever was, I'm sure. So I mean, Revise, sort of helped with those kinds of things, but what that basically meant was that it reduced the frequency of your restarts, but each restart was still very painful, and so that seemed like the next kind of frontier. And I ran a lab, not primarily working on Julia, and so I would occasionally, sort of pester people like Jameson and Jeff and see if they were interested in working on this problem. And there was never very much enthusiasm for working on it. And again, that's because they had so many other priorities, and the work that they've done has been so incredibly impactful. But this one thing that really mattered a lot to me didn't really have any takers. And I can remember, I think this was a conversation on GitHub, and I don't remember whether it was Jeff or Jameson, but one of the two of them made a comment like, it's not even obvious that if we saved the compiled code, it would be all that useful, because the reality is we have to actually throw away so much Julia code that you might do all this work to compile it, but then you don't really get the benefit of it. And I didn't even understand at that time what that actually meant, right? But I eventually learned. And so where does this come from? Where this comes from is that when an interactive language like Julia, so interactive languages are very different from static languages in this regard, right? In an interactive language, you can grow the system by loading additional code at any point in the life cycle, right? And so, but yet when you run code, you need it to be compiled. So at a certain point, there comes a world in which certain methods exist, and you decide it's time to compile this code, right? But now at some point later in your session, you may load additional code, right? And that may bring in additional methods of function, additional methods. And some of those methods might be essentially enhancements, extensions, specializations of functions that were already previously defined, right? And so at that point, you have to ask yourself the question, the function that I called at this point in this previously compiled code, what if it dispatches to this new method that got loaded, right? Or what if it should in this brand new world of new code that I've now loaded, right? So maybe that call is no longer valid. Maybe we wouldn't compile that in the same way now that we did back when we first compiled it. And that's this process of invalidation. And that was the key. Adding that was actually the key magic to Jamison's fix of this issue 265. So invalidations are a phenomenal, wonderful thing, right? You have to have invalidations in an interactive, dynamic, compiled language like Julia, right? The system falls apart in a sense if you don't have them. But at the same time, they were a big threat because with packages, you have to compile them in their own ICE. You don't know what the user's going to load. So you spend a lot of time compiling all these methods in a world that's really just the packages world, right? And then if it turns out that pretty much any arbitrary combination of packages that you load invalidates a bunch of methods, then you've done all that compilation for no value whatsoever. And so eventually, I started understanding a little more of what Jamison was talking about there. And I asked, well, like, how common is this invalidation anyway? And, at that point, like, pretty much like Jeff and Jamison, maybe Kano, were about the only, and I think Kano's mostly worked on other things. So it might have just been Jeff and Jamison. Probably the only two people in the world who had any kind of sense of how common it was, and I think even they may not have had a full sense because we just had no ways of measuring how common this was. And so I, again, in sort of the way I typically approach these things is, well, let's get some measurements of what's actually going on under the hood and try to start.
Scientist view.
Yeah, exactly. It's the scientist view, right? So I just started, sort of trying to figure out where in the code base did these invalidations happen, because I didn't even fully really understand that, or I guess I may have known but didn't understand it all that well. And how do we start making measurements of them? And then I wrote this package Snoop compile that originally had other things but sort of extended. And I think now that's actually the most important function of Snoop compile is to be able to help you understand these invalidations.
Oh, for sure, yeah.
And so I started measuring these things, and I was instantly appalled. Like, oh my God, we are throwing away like more than half of the compiled code pretty much any time you load a brand new package, right? I mean, in many circumstances. And so I kind of started. So my first step in this area, this is a very long answer, Chris, to your question about how did I get started on pre-compilation. But basically, once I developed this tooling to actually measure. So basically, I developed this tooling to measure how frequent invalidation was because I thought, well, okay, if the barrier to pre-compiling packages is that it would be a waste of time because of these invalidations, then maybe the first thing to do is fix the invalidations, right? So having created tools to capture and measure these invalidations, I then started on a very long quest to just stamp out as many of Julia's own internal invalidations as possible. And I found that there were all kinds of places in Julia's code base where there were type inference problems. And I didn't know they were there. They weren't really affecting performance in a very significant way. But it turns out that that's the main category of programming design flaws that makes your code vulnerable to being invalidated, right? Is when the compiler can't be sure which method will be called in advance. And so it's an open-ended question, and you have to acknowledge the fact then that maybe a new method will supersede it. Whereas if all the types are really well inferred by the compiler, then the compiler knows which method is going to be applicable, right? And you have to do something really evil like type piracy to actually cause an invalidation at that point, basically, right? So yeah, so basically that was on almost year-long quest, and that kind of happened in the Julia 0.6 I think era, basically, if I'm remembering correctly. wait, no, 1.6, right? I'm an old timer,
Yeah,
so
much further.
yeah, exactly, much farther along, right? Exactly, and I think we made a lot of improvements. I mean, it didn't drastically change, I think, the user experience. I think one thing that it did change was just this experience of, it used to be the case that you might get something running, you might call a few things, and then you would do something like just load one other package, and then all of a sudden, just like your REPL would hang for half a second, and anytime you tried to run a package command, it would hang for 2 seconds to compile it, right? So any kind of benchmarks that you collected on how fast things were didn't actually change that much. But the user experience, I think, improved actually quite a lot because of that, because it's those sort of almost unmeasurable, well, I did one thing and then I loaded a package and then I did another thing, that where those changes had at least a small amount of impact. But the big impact I felt there was basically I was clearing Jameson's excuses for not working on package pre-compilation, right? So then I basically parked it and waited for like 3 years, hoping somebody else would be dumb enough to tackle this problem. And when nobody did, I just had enough at that point and said, okay, I'm gonna launch into this basically. And so I started working on this actually, and a lot of the groundwork, again, it wasn't very visible to users, but to be honest, a lot of the groundwork was laid in the 1.8 era. We had to solve some fairly annoying, long-standing problems in how the compiler represented certain things. And a lot of that work actually got done during the 1.8 era. Again, didn't make a dramatic impact on compile times, but it really paved the foundation. And, I mean, the work that, Valentine and Jameson and I did in 1.9 was an even bigger effort than the work that went into 1.8. So I'm not trying to in any way say it was easy from that point on, but it was essentially over 2 Julia releases. We went from pretty limited ability to precompile to essentially exhaustive ability to precompile stuff.
Yeah, so I mean, so that tracks your, 2012 coming in, say, I just work on neuroscience. Let me just help with some array types, all the way to, I mean, if I had a certified compiler engineer card, I could give it to you right here, right? So after this whole journey, this brings us now to, now we're at 2024. We have, Revise, we have package images, and these are all, thanks to you, what is then the next things on your sites for how should the language and Julia and its compilation, how should that evolve, and what are you doing to further those directions?
Yeah, so I think there's still a lot that can be. I mean, first of all, I think Julia is in really terrific shape right now, right? And at least I don't have any sort of
Does your lab use
independent.
it yet?
Wait, what?
And does your lab use
Oh
it now?
yeah, right. I mean, at this point, it's yeah, right. It's the default choice in my lab now, right? And I think most people who give Julia a serious try really like it, because there's an awful lot to like about the language, right? So, I'm very confident now of Julia's future. Um, um, there's still a ton we can do. As good as the loading times and people did, Cody, Jameson, Gabriel did a lot of really nice work on decreasing Julia's time to load packages. So I talked about the time to compile code, but there's also just loading the code is something that has actually now one of the main, sort of sources of slowness in using Julia. And it's not that bad, right? I mean, we're not, I would say in aggregate, we still feel a little slower than a language like Python in that regard. But of course, you're willing to take some hits in certain areas in exchange for the benefits that Julia brings. But, in some areas, we're getting pretty competitive there. But the honest reality is there's still, I think, quite a lot of room for improvement in the load time of packages. I mean, maybe an order of magnitude, right? And so I do think that, that's not going to be a simple thing to implement, but I think that's one area that I think would really have a lot of impact. And just again, a lot of using Julia is not just that it's really useful and insanely productive. It's just plain fun, right?
Yeah.
And taking some of these barriers away is really adds it takes away the cuts that you get while using the language while preserving all the fun. So, I think these kinds of changes are really great and impactful changes. There's a lot of I would say one of the I mean there's a work, again, I'm not involved in any way in this, going on to do static compilation in Julia, and I think that's going to be huge. And it's a very hard problem, and it's not something that's going to be like the flip of a switch and now it's solved, right? So, I think what's going to happen is we're going to get the technical infrastructure to do static compilation, but then we're going to go through a phase that was a little bit like my big invalidation hunt, where there's a renewed need to improve the engineering quality of code bases to make them more friendly to static compilation. And the people who are working on the static compilation, I think, have put a lot of time into that already. So they're making things even better than they are now. But I suspect that the community there's going to be need for many hands to be looking at this across packages and other things like that over time. So that's work that's going to be enormously impactful, but its impact, I think, is going to unfold over a couple of years, basically. In most ecosystems. Chris, your ecosystem is probably so well already ready to go that there's going to be some stuff, a subset at least of the things you care about, that may be good coming out of the starting gate, basically.
Well, I have 800 commits already going towards trying to make sure that we're going to be ready for
that you're ready for this brave new world. Yeah. No, and I think
it's going to be a lot of work. Yeah,
it's going to be a lot of work, but it's going to also be hugely impactful, because I love the way that Elliot Saba sort of put this. Elliot is someone who's worked a lot on the bringing the C libraries, making them accessible to Julia packages, so bringing the world to Julia. And Elliot said, the static compilation stuff, this is really something about bringing Julia to the world, right? I mean, I think we're very soon going to be in a place where it's at least technically possible, and there's going to be a lot of problems we have to solve. Library versioning and all these kinds of things are going to be really painful, I suspect, technical problems to solve, but where we'll be able to bring the advantages of Julia to users of Python and R and other languages, where we can write the core guts of some important computation in Julia, and then they can call it from the language that they're comfortable in, right? And I think that's going to be great, because those of us who also are academics and who write papers, and here I've got some cool new machine learning method that that I've created, and I want to have impact on the world. And at this point, still the Julia user base is a relatively modest fraction of all scientists, right? But if I can simultaneously target Julia users and Python users and R users and MATLAB users, then all of a sudden there's no limit to my impact. And by developing my code in Julia, I'm actually reaching a larger audience than I would if I'd chosen any other language, even Python, right? And so I think that's a very exciting and impactful sort of future direction Julia is going in. And then the final sort of really big thing that I think I foresee is that, Claire Foster's doing, in my view, really essential work on improving something that I call provenance, which is, and sometimes called, I've heard other terms for it. Now I'm blanking on what those other terms are. But anyway, basically it's keeping track of where code came from, and in some cases, how the different stages of compilation made certain decisions, basically. And it's in my mind are really essential. And the simplest example of this might be line numbers, right? When you write code and it throws an error, you'd really like to know which line number that that error came from, right? Well, the reality is that line number has to essentially be passed down. It starts out as the source code you type, and then there's like 5 layers of compilation that happen. And one of the things the compiler does reasonably well now is at least keep track of which line number a given statement came from, right?
I remember the version 0.4 macros where it would have a line number, right? But it wouldn't change your line number if you had a macro expand something out, right? So it would be in the wrong line.
Exactly. And it's amazing how much harder it makes that sort of development, right? Mm-hmm. Well, now imagine that you want to do, like one of the things I actually also helped write was Julia's debugger, right? So, you want to actually debug, Julia code. Well, it turns out that what you really want is you want to know, actually, you usually want to target the debugger to a deeper level of the compile chain. But yet you need to relate it back to the source code that the user actually sees in front of, him or herself, basically, right?
Oh, you don't want to show them a lowered type IR optimized LLVM?
Yeah, believe it or not, exactly. That's right. So this ability to sort of like communicate across layers of the Julia compiler, I think, is a really important and impactful thing. And we have this only in limited rudimentary form right now. And so Claire is doing some amazing work on trying to change that. And she's already done she already made major improvements in Julia's parser, and the error messages that we get now from syntax errors are often just a really dramatic improvement. And there are other categories of error that happen later in the compilation pipeline for which that hasn't happened yet, but that I think will be an immediate win. But I think the even bigger win will just be that there's a lot of tooling that I think should be rewritten once that work lands, right? The debugger should basically, be rewritten and probably targeted at an even deeper stage of the compilation pipeline. I think not only will we be able to make the debugger more usable and more accurate in terms of actually being sure that we're sort of interpreting the code as stepping through the code in the way the user would kind of expect. But I think it could easily get at least, I've timed this and I thought maybe we'd get 1 order of magnitude. I got 2 orders of magnitude, and there might be a 3rd order of magnitude that we can extract, from that. Both certain, we actually need a new intrinsic in Julia. But if we can do that, then I think the compiler, the debugger could become enormously faster.
And is that from getting rid of the Lisp code? Because I know that there was some Lisp in the front end, right? Or is this from a
no? It's so basically it's simply that we have to solve. So the issue is the deeper you track in the compiler, then the more stages there are to go backwards to figure out where it is. And here's the real problem. If you're debugging code, you'd like the user to be able to ask, well, what's the value of X assigned at this particular point, right? Where the debugger's targeted currently is the last plausible stage at which we can report back the value of a particular variable. The layer that it should be targeted at from a performance standpoint is in the so-called SSA form. And we have no record anymore of what SSA values correspond to which variables at that point
you could just, percentage 15 equals 1. Yeah.
Exactly. That's right. So yeah, so we need to be able to keep track of that kind of information. Then we can target our interpreter at the optimized, type inferred, method dispatched, method lookup finished, stage of the code. And again, in my benchmarks, this got me an additional 2 orders of magnitude of improvement in the interpreter performance. And the interpreter is really kind of the foundation of the debugger, basically, right?
Yeah. Well, I mean, you heard it here, folks. Tim Holy is guaranteeing you that the debugger will be 3 orders of magnitude better next year.
Hardly a guarantee, but this was a benchmark I whipped up in a couple hours, but it was very encouraging, right? So, and I mean both the usability and accuracy of the debugger and its performance are the 2 main bottlenecks to debugging Julia code via a debugger, right? So I use basically printf debugging in Revise in most of my debugging, right? Because for me, that's actually more efficient most of the time. I mean, I also step in with debugger.jl, but I'm selective about which things I step into. And the thing that I use most of the time is sort of printf debugging. And that may continue, but when I was using other programming languages, I loved the debugger, and I used it all the time, right? And that can actually encourage some bad habits because you rely, instead of writing test suites, you just watch your code work, and that's actually long-term very destructive to the quality of a code base, but in the short term, it's very efficient.
So something that I now realize as we speak is how. So obviously you care very, very deeply about user experience and developer experience, but also how closely the tool chain and the compiler backend immediately connects to the user experience.
Absolutely.
Let's say in the front end. So
Julia is extraordinary in that regard because we have such a unity of the compiler with the code that people are writing. And this provides for an amazing opportunity to communicate deep understanding that the compiler has about code all the way back to the developer. And yet in order to do that, you need good tooling.
So one thing that makes me wonder about this is, do you think that this is also the flip side of a coin where you need to understand a lot about the compiler technical details in order to be writing very good or efficient code? Or you also mentioned earlier that you expect the upcoming work will really allow us to interface with the different languages much better. Like, thinking about the people coming newly to Julia and then having to experience this sort of very immediate touch point with the compiler, like what do you think will happen there?
Yeah, so to be clear, you need to have a deep understanding of the compiler if you're writing tooling that communicates back and forth between the compiler and the user code, right? But that's a very small number of people who really do that kind of work, basically, right? You ask a really good question, which if I might, sort of ask whether I can address it in a slightly different way, which is basically like, how do we create tools that allow Julia users to become writers of high quality code, right? And by high quality code, I mean several things. First of all, it runs fast, it doesn't waste a lot of resources, and it's not vulnerable to being invalidated and all this kind of stuff, right? This is how do we basically take people who may not have an extensive programming experience and may not have invested the kind of time I have in terms of understanding the fundamentals here, how do we nevertheless sort of steer them towards writing high quality code? And this is a very important and interesting question. I also teach a lot, and I'm really quite passionate about this kind of sort of thing, and I think it's really important. So I don't have a full answer to your question, but here is a portion of an answer. A portion of an answer is that the tooling can really help grow the developer, right? And so what I mean by that is that, all people who work on code, they have very important decisions to make. But one of the factors that I strongly encourage my trainees to work on, and I would encourage all burgeoning programmers to do, is to remember that oftentimes the most important product of working on a piece of code is not the code, it's the developer who wrote the code. And by that, what I mean is you might be working on a project, you might be working on a little bit of code that's a tiny portion of your pipeline, and you might need to only run it once or twice, right? And the first time you write it in Julia, it takes 10 seconds. And let's imagine you have some inkling of what should be possible and you think it should be able to be done in 1 second, and you use the at time thing, and you can see there's lots of allocations and all this kind of stuff. And so you've got some reason to believe maybe this bit of code could be better in some way, right? So you could tell yourself, sure, but I'm only going to run this a couple times. It may not be worth optimizing. There are going to be moments of time where that's really useful to do. But what I usually tell people is like, no, use this as a learning experience. Use this as a test case. Say, yeah, this is a dumb, stupid bit of code I don't really care that much about, but I'm going to spend a whole week learning how to write it well. And the end goal of that is not really to have a great piece of code at the end. It's for me to be great at this stuff, right? And so, what I would say to them people is learn, sit down, make yourself a nice cup of coffee, a nice cup of tea, and just start reading the documentation on the profiler, right? And profile the code and see where the bottlenecks are. Open up the profile in profile view. Look at the flame graph. You look for these big red bars that indicate you've got a type instability, somewhere in your code base. Learn a little bit about that and what that means. Click on the bar, and then sit down and read Cthulhu's documentation, right? Now that's a daunting thing. I'm not trying to say that that's trivial, but
I mean, it's named to be very daunting in the first place.
The name is daunting, and it's actually gotten a lot friendlier recently because we've really sort of hacked some of these provenance issues. It's not what I think the solution ultimately should be, but it's been a surprisingly effective hack to try to bring some of the information about type inference back up to the level of the Julia users code. And I think in the early days, you really had to learn how to read Julia's, not the full SSA form, but the type inferred code in order to use Cthulhu well. But I think now the reality is that most developers who are past the basics of learning how to write code can, if they just invest in themselves, they should be able to learn how to leverage Cthulhu. And once you start seeing the types that get attached to your code, and I should say to anybody listening, beware, because we haven't fully solved the provenance problem, Cthulhu isn't always perfect in the type annotations it provides, right? So there is some level of error, but it's pretty darn good. And I think it will teach you an enormous amount about what's actually going on in your code and under the hood if you put in that hard work of learning to use these tools. Because once you come out the other side, now all of a sudden you are a different person as a Julia developer, right? And you should be able to understand better what kinds of changes you need to make to your code base. And you have now a systematic set of procedures that you can go through to learn to write higher quality Julia code. I'm not saying that this is the answer to every performance problem in Julia. There are other tools that you need as well. But I think for most people who are new to Julia and who, I mean, this happens even to me. I sometimes write code that has a surprising, type instability, and I didn't anticipate this, right? So everybody, I think, benefits from some tools to help them uncover these things. And I think that's the big divide between people who start out with relatively rudimentary Julia skills and wonder whether they can really ever write fast code in Julia. Once you go through that process, pretty much it's there aren't any barriers left. So I really think it's much more of an education question and deciding to invest in yourself than at this point a technical question. We can make that better, but I think it's really I think we're getting very close to having a good solution in place for that.
Yeah, two things. One quick thing is I did hear from Valentine that he did want to rename Cthulhu into Cuddle Thulu because he made it too easy now. The second thing is, just I think this will be my last question here is, because you just started talking about how, the interpreter is getting so much faster.
Well,
and,
could get it
about,
faster. It's not getting any faster yet. Right.
Yeah, but could there be a future where we actually are using the interpreter for some fundamentally type unstable code for something like plots, right? Should plots.jl, could it actually be a thing for a Julia developer to be able to say, hey, we're in a just-in-time compiled language, but this piece of code actually would run better as interpreted. Let's switch over to this type of behavior to be more Python R-like for these kinds of codes, or and have a bit more control over that. Do you think that could be part of a future solutions, or have you considered it?
I don't think there's a fundamental barrier to do that. I mean, we don't have infrastructure right. Once you enter the compiled chain, there is no exiting from it at the current moment in time, right? So we would need some hooks to sort of launch an interpreter. And I mean, one of the things, it's an excellent question that you raise, and one of the things that points out is a lot of the things that are currently packages like Revise, like the interpreter, I mean, there's already an interpreter in Julia. We already interpret code, but it's not an interpreter that's usable as a debugger because it doesn't support things like breakpoints and all those kinds of things. At some distant future, we should probably have shared core guts in Julia itself, where the core interpreter is actually the same thing, and it's just that the package is just a wrapper around it that leverages facilities built into Julia. And I think if one gets to that point, it would be more conceivable to do the kind of thing that you're talking about there. Because I think there's so much gain to be had of targeting the interpreter to a lower level of Julia code after type inference. So would have run the early stages of compilation. I suspect, again, we just want to wait until the provenance issues are really well worked out before anybody even tries those things.
And waiting is a very good thing that you mentioned right now, because looking at the time, I actually have to pick up my kids from childcare soon, so we'll have to cut it short here. But what this told me is, I hope a lot of people found this as interesting as I had. I had so much fun and just exciting moments, listen to your passion, learning a lot here. And if people will listen to this, I'm pretty sure that this will give us enough of an excuse to invite you over pretty soon again. I'm looking very much forward to it.
We haven't even asked about images or neuroscience.
Yeah, there's so much to talk. We can maybe reveal that we had a script planned and we went completely off board, and we just got like maybe touched 50% of what we wanted to talk, and there's even much more. So thank you so much for being on our show, for being this first guest. It was a great time. Hope you had a great time as well. Thank you so much.
I did. Yep. Thanks a lot. All right.